Welcome to our poster presentation. The title is Approximating Particle Surface Roughness with Chebyshev Particles. We do know that particles have surface roughness and non-sphericity, but in practical calculations, ideal shapes are often assumed, for example like spherical or spheroid. This raises questions. Do ideal shaped particles give significant optical characteristic differences from their real shapes? To answer these questions, we use Chebyshev particles. The shape of Chebyshev particles is a sphere deformed by means of Chebyshev polynomial order. Chebyshev particles have two parameters. First, waviness parameters are also known as Chebyshev polynomial order. Second, deformation parameter. We use Chebyshev particle to explain about non-sphericity. For example, in aluminum oxide particles, based on the same image of aluminum oxide particles, it could be modeled as Chebyshev particles of T4 15,000 that is more representative than spherical particles. We also study Chebyshev particles to explain about surface roughness, for example in hematite particles. Based on the same image of hematite particles, we can model the surface roughness of it as Chebyshev particles T45 500. The methods we use to calculate the optical characteristic of Chebyshev particle is T-matrix that is based on extended boundary condition method. In this method, the incident and scattered field are expanded into vector spherical wave functions. These expansion coefficients A, B, P, and Q are related by T-matrix. To calculate the T-matrix, we use extended boundary condition method. In this method, we need to find the surface integral equation for incident and scattered field. To get the general idea, first, after we have the incident field, we can calculate the transversal component of electromagnetic field on the surface of the particle. And then we can substitute it to the scattered field equation to get the scattered field. Optical characteristics such as extinction and scattering cross-sections are calculated from the T-matrix. The Chebyshev particles has the general formula as shown, where R0 is the spherical radius, psi is the deformation parameters, N is the Chebyshev polynomial order. From our calculations, we found that the influence of waviness parameter is observed in larger size parameter. In this calculation, we use the properties of silicon as the scattering object. We can clearly see from these plots that when size and waviness parameter increase, the optical characteristic, for example like absorption cross-section, increase too. We also found that the influence of deformation parameter is observed in larger size parameter. In these plots, we use the properties of silicon as the scattering object. We can clearly see that when deformation parameter and size parameters increase, the deviation from the spherical particles is higher. Then, we found that the influence of wavelength is observed in smaller wavelength. In this calculation, we use polydispersed silicon as the scattering object. We also found that significant deviations are observed when the real part of refractive index is larger than 1 and imaginary part of refractive index is equal to 0. In this calculation, we use polydispersed particle as the scattering object. We also found that different patterns are observed in phase function and linear polarization degree. In this calculation, we use polydispersed silicon as the scattering object. We conclude that there are some deviations affected by non-ferricity or surface roughness of particles. So one should take a careful assumption when calculating particles' optical characteristics with ideal shaped particles. The deviation appears to be in many optical characteristics, such as scattering, extinction and absorption cross-sections, asymmetry parameter, single scattering albedo, phase function, and linear polarization degree. By approximating the surface roughness of particles by Chebyshev particles, larger waviness and deformation parameters tend to give larger difference from ideal particles in optical characteristics. So the optical characteristics could be controlled by modifying these parameters. Chebyshev particles could not perfectly approximate the surface roughness of particles due to their nature of regular shape patterns. A study of another particle shape is needed to approximate the surface roughness better. Thank you for visiting our poster.